Hey everyone, welcome back to yet another Euphoria Academia YouTube video where we do past papers and hopefully we help you excel. My name is Ole and I'll be taking you through it. Today we're going to be doing the grade 12 mathematics paper 2 November 2022. So without further delay, let's get into it. We are going to be doing question 3 to start off with, and question 3 is out of 20 marks. It ranges from question 3.1 all the way up until question 3.3.2. For question 3.3.1, we're asked to find the gradient of AB. So let's get into it. Now, what's the formula of the gradient? The formula of a gradient is m, and in this case we're trying to find the gradient of line AB is equal to y2 minus y1 over x2 minus x1. Now I'm using this formula because on line AB we have two known points. Alright, so let us do some substitution. We're going to find that, well, it doesn't matter how you substitute it, you just have to keep the consistency of the substitution. Alright, so let us do that. And we will end up with, at the top, minus 4 minus 2, that's minus 6. At the bottom, 6 minus 4 is 2. And the gradient of AB is minus 3. Alright, so we're asked to find the alpha, the angle of inclination of the line AB, and the formula is the gradient of AB will be equal to tan alpha. So let us substitute the gradient, which is minus 3. And we can already see that the gradient is negative, which means that this is decreasing. So whatever value that we do get, that is going to be our reference angle. All right, so let us find the arctan. The arctan will be given as, so the reference angle of alpha is going to be minus 71.5650, and it continues. Now to actually get alpha, it will need us to add 180 to this reference angle. So plus 180 degrees, our alpha, we'll find that as 108.43 degrees. In 3.1.3, we're asked to find the coordinates of T, and T is the midpoint of CB. Alright, so we already have the points of C and the point of B, so we're just going to apply the midpoint theorem. Alright, so the x-coordinate of T will be equal to minus 2 plus 6 divided by 2, and the y-coordinate of T will be equal to, let us find minus 3 plus negative 4 divided by 2, and we will find that xt is equal to 2, and yt is going to be equal to minus 7 over 2. Therefore, the coordinates of t are 2 and minus 7 and over 2. Question 3.1.4, we're asked to find the coordinates of S, and S is the y-intercept of the line AC. Now, in the question, we're already given the formula of AC. Formula of AC was given to us as 5x minus 6y is equal to 8. Now, if we're told that S is actually the y-intercept, that means x should be 0, and we're just looking for the y value. So let us substitute x is equal to 0 minus 6, y is equal to 8, and we will find that y is equal to minus 4 over 3. For question 3.2, we're told, we're told to determine the equation of CD in the form of y is equal to mx plus c. Now, we know that CD is parallel to AB, which means that the gradient of AB is equal to the gradient of CD, and that gradient is, we found it in question 1, is minus 3. All right, and we have a point for the line CD, and that point is C. So all we're going to do is just sub in C into the gradient point formula, right? Which is y minus y1 is equal to mx minus x1, and we're just substituting the point minus 2 and minus 3, and when we do substitute, we're going to find that we have y plus 3 is equal to minus 3x plus 2, and the formula after some algebra is going to be y is equal to minus 3x, that's going to be minus 6 minus 3 minus 9. Alright, for question 3.3.1, we're asked to find the size of the angle DCA. Now, let's just find where DCA is. DCA is right here. So we're trying to find this angle right there. And the best way is to try and relate this angle to all the angles around. Now, in this question, we're told that we have parallel lines and this angle is quite close to 1, so it might be related to something. So line CD is parallel with line AB. Alright, and I can see that there's a transverse line here. So let us also draw that out. And this creates a Z, depending on how you look at it, but it's a Z or N. And once you see a Z or N, you will understand that we're working with alternate angles. So the alternate angle here related to the angle that we need to find is there. Alright, so we need to find that angle. What else do we need? Well, we have an alpha here. We might just need to find this angle. And this angle is actually the angle of inclination of line AC. So let's find the angle of inclination, and after that we can relate that to this exterior angle, and we shall have what we need to find. So without further ado, let's get into the question. Alright, so we know that the formula of the angle of inclination is m is equal to tan theta. Now, we were given the equation of the line AC, but it was not in the conventional way. It was given to us as 5x minus 6y is equal to 8, I believe. And once you turn this into standard form, we'll be able to see what the gradient is. And when we do that, we see that y is equal to 5 over 6x minus 4 over 3. Now from that we can see that our gradient is 5 over 6, and that is equal to tan theta. Now the gradient is positive, so we don't have to worry about reference angles or anything like that. And once we apply the arctan, we can see that theta is equal to 39.81 degrees. Now we have theta. Let us see how we can relate all of these to the angle that we're trying to find. So we know that our theta plus the angle indicated, RAF, is equal to 108.43 degrees. The reason for that is we're working with the exterior angle. Alright, so therefore, I don't know if, okay, I think let's just replace it here. Plus RAF is equal to 108.43 degrees. And if you just do some algebra, we shall see that our angle RAF is equal to 68.62 degrees. Right? And like we said earlier, our RAF is equal to the angle we're asked to find, DCA. That is also equal to 68.62 degrees. The reason for that is alternate angles, because CD is parallel to AB. Alright, for the last question, for question 3, we're asked to find the area of POSC. So let us find where POSC is. We'll start at P, draw a line to O. From O, we'll draw a line to S. From S, we'll draw a line to C. And we'll just connect everything. Now we can see that the shape POSC is a quadrilateral, but it's not one of those that like we know the formula of. So whenever you work with a quadrilateral where you don't know exactly what shape it is and what formula to use, it's best to divide it, or I guess describe it in a way where you know the subdivisions of it, you know what shape they are and what formula you can use to find the area. Alright, so I'm going to draw it here on the side and just see if we can figure out something. This is not going to be to scale, whatever. Alright, so we have P there, we have O there, and we have S there, and we have C. Alright, so I'm going to divide it like this. So where we have S, I'm just going to draw a straight line. I know it doesn't look straight, but it is a straight line. And then from that point, actually no, that doesn't divide it well enough. Okay, let us erase all of that and just see what we can end up with. Okay, let us draw a line from C going all the way up vertically so that it intersects this line PO at 90 degrees, and we're going to divide this again to make it a square. So essentially we just need to find that point there. Maybe let's call that point Q. We need to see if we can find point Q, and then what we can see, we have a square and two triangles. I know it doesn't seem like a square here, but let me try and do it on the diagram so it's more evident. All right, like I said, we're going to draw a straight line, okay, from C going up, and that point there is Q, and we're going to draw a line just touching the line QC from S, and that point, maybe we'll call it point X. All right, so we have a square and we have two triangles, so that would mean that the area of POSC will be equal to the area of the triangle CPQ plus the shape Q, or the square rectangle QOSX plus the triangle SXC. All right, so we essentially know all our points. We know O, we know S, we know even the X and the Q, because they lie vertically or horizontally from points that we know. We know their coordinates. The only point that we don't know is point P. All right, so point P is actually the x-intercept of the line CD. All right, so that means the y value is 0. So let's just substitute that into the formula that we know, which is also on the diagram and we found earlier on in the question. And that is, I think, yeah, let's just sub in what we know. So we'll sub in, we're trying to find the x coordinate of P. We know that the y coordinate is 0. So as we sub that in, it's going to be 0 is equal to minus 3xp minus 9, take 9 to that other side, xp will be equal to minus 3. Alright, so after knowing that, let us just substitute everything into our formula. And I think to make things simple, let me just write the points that we might not think we know, but we actually know. So point Q is vertically up from C, so that will have the x coordinate of minus 2, and it's on the x-axis, so there's that. And then point X is also on that vertical line, and so it have a point of minus, an x coordinate of minus 2 and a y coordinate of minus 4/3. And yeah, we just got P has 3 and minus 3 and 0. Okay, and this distance here from S to X, that distance is actually 2 units. All right, and then yeah, that distance from O to S is 4/3 units. So we have everything that we need. So what we're going to do is just substitute into this formula here our area of POSC is equal to half the base of the triangle CPQ. That is going to be 1. So half of 1 times the perpendicular height, which is 3 units. Yeah, it is 3 units. Yeah, half times perpendicular height plus, now we need to find the or we have that this is length times breadth, right? So it's going to be 2 units multiplied by 4/3 plus, now the other triangle is going to be half of 3 minus 4/3, because that's the length of the base, right? And then that will be multiplied by the perpendicular height of 2, and we shall get a result of 50. Let me just put it in the G's for the break in communication, but for the previous question, the answer was 5.83 units. Units squared, actually. Right, we have enough time to do question 4, so let us get into it. It's for 20 marks from 4.1 to question 4.4.2. For us to find the coordinates of P, and the coordinates of P, we can see that they are on the circumference, and the line PN is a diameter, and a diameter passes through the center, and the center is the midpoint. So we have to use the midpoint theorem. All right, so we know that 3 is equal to the x coordinate of P plus 7/2, and minus 5 is equal to the y coordinate of P minus 2/2. And once you do some algebra, you will see that xp is equal to minus 1, and yp is equal to minus 8. Therefore, the coordinates of P are minus 1, and minus 8. 4.2.1, we're asked to find the equation of the circle in the standard form. So to begin with, we already know that the center M has the coordinates 3 and minus 5. So we can already put that into our formula. That will give us x minus 3, all of that squared, plus y plus 5, all of that squared is equal to r squared. Now to find r squared, we'll just sub in the known points. We already have P, we already have N, but for me, I think let's just see what N has for us. It doesn't matter which one you substitute, you're going to arrive to the same answer. Now, when we substitute, we're gonna put x equals to 7, and we're gonna put it there. And yeah, let's just substitute, honestly. Is equal to r squared. Now, when you put that into your calculator, you will find that it is equal to 25. So 25 is equal to r squared. And if you're curious to find the radius is just the square root of 25, which is 5. So therefore, the equation of this circle is x minus 3 squared plus y plus 5, all of that squared, is equal to 25. Right, so for question 4.2.2, we're asked to find the equation of the line KL in the form of y is equal to mx plus c. Now, we first need to get the gradient of it, and we don't have 2 points, only have 1 point. However, on the line PN, we actually have 2 points, well, 3 points now. So that means let's get it from there, and we know that that is actually the diameter, and diameter is just radius times 2, and that will be perpendicular with our tangent KL. So we can use that to find the gradient of KL. So let's get into it. So the gradient of PN is going to be y2 minus y1 over x2 minus x1. So let us do some replacing. Doesn't really matter which of the 3 points you decide to choose. I'm just going to say -2 plus 5. And then at the bottom, it's going to be 7 minus 3. And that will give me an answer of 3/4. Now, like we said, we're going to use this gradient to find the gradient of the line KL. We know that the gradient of Pn multiplied to the gradient of KL is going to give us -1, which basically means that they're perpendicular because the tangent is perpendicular to the radius. Alright, so that is going to be 3/4 times MKL is going to be -1. Therefore, the gradient of the line KL is going to be -4/3. And we have the gradient and we have a point on the line. So we're going to use the gradient point method to find the equation of the line. And it is written as the following: y minus y1 is equal to mx minus x1. Now let's sub in the points that we do know. So we're going to sub in the point n, which has the value 7 and -2. And we have our gradient already from the previous calculation. So that's going to be y plus 2. It's going to be 4/3 x minus 7. And once you do some mathematics and algebra, you'll find that y is equal to -4/3 x plus 22/3. For question 4.3, we're asked for which values of k will y equaling -4/3x plus k be a secant to the circle. So secant is a line that cuts the circle at 2 distinct points. Okay, so already we have a tangent which touches at 1 point, and this tangent is KL actually, and what we're given is actually very, very similar to this tangent formula, because we're asked for which values of k, right? Plus k. So we're asked to find the values of k. So what we're going to do is actually sub in a point that we find on the diameter that crosses the circumference. So we're going to sub in our point P, and when we do that, we find that that is going to be equal to -4/3. That's going to be -1 plus k. Well, I think let's just refrain from using k. Let us rather use c. So a constant of any, the constant that we're going to find, it's going to be -28/3. All right. Now, essentially, what this means is that for our secant formula, right, we know that our tangent formula is y is equal to -4/3x plus 22/3. Now, this will touch the circle at 1 point and 1 point only. But if our c value is all the way here at our P value, at our P points, there where it's -1 and -8. That means that's the extreme end, but it also shouldn't touch there essentially. It's only going to touch it once. Once you start moving this line that we have into the interior of this circle, once you start moving it there, then it's going to touch at 1 and 2 points, which is a secant. So it's going to do all of that up until it gets to this line KL, this tangent line here. So you probably want to have values of that constant that are between this P value, so where it touches there, and where it touches at N. And how you write that mathematically, it means that for values of K where K is between, now found that that's 28/3, it's between -28/3 and 22/3. In 4.4.1, we're given a story that there's a point A with values T and T, and as well as B, but like these points are not shown on the diagram. And then from point A tangent is drawn to point B. Right, that's very important. Yeah, so it's touching the same circle, and we need to show that the length of AB, the tangent AB, is given by that formula over there. All right, so I think there's a lot of abstract math going on there, so I'll try and do a diagram here. You can also do a diagram for yourself. So pretend that this is our circle and that is M, and we have a point B on this circle somewhere. I think let us choose that top point to be B, and if that top point is B, well, we're going to have a line drawn from A that touches the circle at B, right? That's our tangent. Or we can have it at, let's just say that point there is B, and if that point is B, then a tangent can be drawn from A to there, or any other point. It's going to be the same situation. All right, so I'll just work with this one here because it's going to be the same. So I'm going to connect AM as well as MB. All right, we know that the radius is perpendicular to the tangent. So there we have it. We have a right angled triangle, and I'm seeing square roots and squares and stuff like that. So that must mean we use an element of trig or Pythagoras, right? So Pythagoras is going to help us. So it means in any situation, we're going to find that the hypotenuse AM squared is equal to the two other sides squared. So MB squared plus AB squared. All right, so we're meant to find the length of AB. So let's make AB the subject of this formula, and that is going to be AB squared will be equal to AM squared minus MB squared. All right, cool. Now we're going to use the distance formula for AM, and we're going to find that for the distance formula, it's going to be the square root. This whole thing is going to be squared. Our AM value is actually, we already have a value for M, So that's going to be 5 minus t squared plus, sorry, that's going to be minus 5. Yeah. That's going to be 3 minus t also squared, and that whole thing is squared, minus mb, well, in all cases that's just the radius, and that is 5 squared. All right, so what we're going to have is, once we do whatever's inside the bracket, we're going to find that ab squared, because that's a square root and we have a square on the outside, we can just cancel the square root. So we're going to end up with a situation where we have where we have, I think, yeah, we can square root all the sides and just see what we end up with. But I think to keep things less complicated, let us just do what's inside the square root, and we're going to find that we're going to have 25 plus 10t plus t squared, that's plus t squared, plus 9 minus 6t plus t squared minus 25, sorry, minus 25, and that is going to give us a situation where we have 2t squared plus 4t plus 9, and then AB is going to be the square root of what we have here, and that is our question. Question 4.4.2, we're asked to find the minimum length of AB. Now, from the previous question, we found that AB is equal to the square root of 2t squared plus 4t plus 9. Now, to find the minimum, we need to essentially ask ourselves, what is the lowest value of t? Well, yeah, what is the lowest value of t? Because that's going to help us determine the lowest value of the whatever is going to be in the square root. Now, unfortunately, you can't see it from now on, so we kind of need to factorize so we can isolate the t by itself. So we can't use normal factorization techniques, we need to use completing the square for that. So we're going to use completing the square, but you can't use completing the square in this form. We need to separate out this 2. So let us take out a common factor of 2. That's going to be t squared plus 2t plus 9 over 2. And when we do completing the square, we're going to look at the 1t. So we're going to say half times 2t squared is going to give us, I like writing this step because it shows me what it's going to factorize as, and that, sorry, this t is not supposed to be there. That's going to give us a 1, and 1 to the power of 2 is just 1. So we're going to replace that into our equation. So t to the power of 2 plus 2t plus 1, and then I'm just going to write 9 over 2 minus 1. Now you have to take away the one that you just added, because if you don't, you're changing the equation fundamentally. All right, so let us do what we need to do. So when we factorize, just going to make big brackets there. When we factorize, we're going to see that we're going to end up with t plus the one that we found there, all of that squared, and then 9 over 2 minus 1 is going to give us plus 7 over 2. And that is inside the big brackets. And when you multiply in the 2, we're going to see that we have 2 multiplied to t plus 1, all of that squared, plus 7. Now, we need to find the lowest value of this square root. Now, we can see that if this bracket here becomes a 0, it's going to be 2 times 0, and that's going to be 0, and we're going to be left with 7. If we have a 1 or even a negative, it's going to be more than 7 because we're squaring. All right, so that essentially means that that essentially means that to make this a 0, t has to be equal to minus 1. All right, so t is equal to minus 1 should be the minimum, and we can quickly check that into our equation. So we're going to substitute that. So AB, we need to find the lowest value, the minimum value of AB. So substituted that minus 1 squared plus 4 plus 9, all of that inside the square. That once you do some maths, you're going to see that we're going to end up with, so that's going to be 2 minus 4 minus 2 plus 9 is the square root of 7.